Question 6, as you can see, is an analytical geometry question focusing on the circle. Now, what information do they give us here? They tell us that M is the center of the circle and that the circle has this equation: x squared plus y squared minus 6x plus 2y minus 8 is equal to 0. And they tell us that tangents are drawn to the circle at R and at N, so we know that this line and this line are tangents. Okay, and they've also given us that the point R has coordinates 0 and 4, and N have the unknowns P and Q as its coordinates. They also show us that the tangents meet at the point P, and that this angle here is 90 degrees. Okay, question 6.1. Show that M is the midpoint through, or not the midpoint, show that M is the point 3 and negative 1. Okay. How will we go about doing that? Well, we know that M is the center of the circle. Now, what do we know about center of circles and how they relate to the equation of a circle? Well, let's see what happens. We know that the basic equation of a circle is x minus a squared plus y minus b squared equals the radius squared. Now, we can see that we need to get this equation into that form because the center of the circle, let's call it C, has the value negative, or it has the value a and b rather. So x minus a, that a value would be the x coordinate of the center, and the b value would be the y coordinate of the center of the circle. Okay, so what we need to do is rearrange this equation so we can get it into that form. And how will we do that? By completing the square. Okay, so let's write down the initial equation first. We've got x squared plus y squared minus 6x plus 2y minus 8 is equal to 0. We want to get all the numbers, the constants, to the right hand side, and that will form our radius. But we also want to get the square, complete the square for the x values, and then similarly for the y values. So for the x values, we will have x squared plus x squared minus 6x, and now what value will we use to complete the square here? Well, to get negative 6x, we'll have to say b over 2, so negative 6 over 2 squared. That'll give us negative 6 over 2 is negative 3 squared will give us 9. So we'll have to subtract 9. And if we we'll have to add 9 because it's a squared, so it'll be positive 9. But then if we added 9, we have to subtract 9 again. So we'll subtract 9. And then for the y values, we've got y squared plus 2y. And then we have to add something to complete the square here. So that'll be, again, this value divided by 2 squared. So 2 divided by 2 gives us 1. We square that, we get 1. So plus 1. Because we added 1, we have to subtract 1 again. And we have to subtract the 8 that we originally had there, equals 0. And now we need to group these things together. So we look at these first three terms first, and we factorize this. We see if we factorize x squared minus 6x plus 9, we get this bracket. X minus 3 squared. Okay, and you can check for yourself. If you multiply that out, you'll get back to this original form here. Now let's do the same for the y values. So we'll go plus, to factorize y squared plus 2y plus 1, and that'll give us y plus 1 squared. And then we'll say equals, now we just take all the constant values that are left to the other side. We haven't used this negative 9 yet, so that can go to the other side, that'll become 9. We haven't used the negative 1 yet, move it to the other side, that'll become plus 1. There's negative 8, move it to the other side, that'll become plus 8. Okay, ooh, that's an ugly 8. So now we're left with the final equation of x minus 3 squared plus y plus 1 squared is equal to 9 plus 1 is 10 plus 8 is 18. And there you go. So now we can see that the center of the circle will be A and B. So where that will be, and we said that if x minus A, that A value there would be our x coordinate of the center. So this 3 would be our x coordinate of our center, and our center was M. So the coordinates of M are therefore 3 and -1. And that's how you find the coordinates for M. Okay, and 6.2, determine MR in the form of y equals mx plus c. So in this case they want the equation, not the distance of MR. Well, we can start off by saying, okay, well, we know we need to get y equals mx plus c. Again, we know that m is the gradient of the function and c is our y-intercept. Okay, this line MR runs through here, and we can see we already have the y-intercept. That'll be -4. So we can already plug that in. We see we have y equals mx minus 4. And now m is the only unknown, so we can just substitute any point on this line into the equation to solve for our m. And we only have one point, which is our r, 0, -4. Well, actually, we've got the m as well, the 3 and -1. So we'll substitute the m in, 3 and -1, and see what happens. Let's say substitute 3 and -1 into the equation. Let's call this equation 1. We'll substitute that into 1, then we'll get -1 is equal to 4 times, m times 3 minus 4. Take the -4 to the other side, becomes -1 plus 4, which will give us 3, and that's equal to m times 3. Divide both sides by 3 and we get 3 divided by 3 is 1 equals m. So now we've got our m and we've got our c. So all we need to do is rewrite the formula in its final form, and we have y equals 1x minus 4. There you go. That's our equation for MR. Now, 6.3. Show that Q is equal to 2 minus P. So this value Q is equal to 2 minus P. Now how will we find that? Well, we can use this property here. We see that that is 90 degrees. What does that tell us about the gradients of these two lines, of the line MN and the line MR? Well, it tells us they are perpendicular. And when they're perpendicular, the product of the gradients are equal to -1. So we're going to say that the gradient of MR times the gradient of MN, must be equal to -1. Again, because we know that M is 3 and -1, we can find the gradient of MR. So let's find the gradient of MR. Gradient of MR is equal to the change in y divided by the change in x, and that is equal to the change in y is -1 minus -4, -1 minus -4 over 3 minus 0, which is 3, and that is then again equal to -1 plus 4, which gives us 3, and 3 minus 3 is 3, which gives us 3 minus 0 is 3, which gives us 3, and that is equal to 1. Okay, so the gradient of MR is equal to 1. So now we know that 1 times the gradient of MN must be equal to -1. Okay, so we divide both sides by 1. We see that the gradient of MN is equal to -1. And now what is the gradient of MN in terms of P and Q? Well, we do again. Gradient of MN is equal to the change in y divided by the change in x. And the change in y is -1 minus q. So that's -1 minus q divided by 3 minus p. 3 minus p, and we know that has to be equal to -1. Okay, we'll multiply both sides by 3 minus p, and we're left with negative 1 minus q is equal to negative 1 times 3 minus p. Ooh, write that p properly. Okay, multiply that negative 1 in, we get negative 1 minus q is equal to negative 1 times 3 is negative 3 plus p. And take the negative 1 across, that becomes plus 1. So negative q is equal to negative 3 plus 1 is negative 2 plus p. Multiply both sides by a negative 1 to get rid of this negative in front of the q. We've got q equals 2 minus p. And QED, as they say. Proven. Next question. Determine the values of P and Q. Okay, so we don't know P or Q yet, so that might be a bit complicated to use one of the two to prove the other one in terms of it. But what we do know is what the center of the circle is and the equation of the circle. Because the equation of the circle we already calculated in 6.1 to find the center. So we're going to probably use that again. Let me just see what would be the quickest way to do this one. Yes, okay. So now we'll say that we'll substitute P and Q into our equation of the circle, because we know that P and Q lies on the circumference. So that means it lies somewhere on the equation. So we can substitute that as our x and our y values. Now let's rewrite our equation of the circle first. We know that it was x minus 3 squared plus y plus 1 squared equals 18. Okay, now we'll replace the x with a p and the y with a q. Okay, so we've got p minus 3 squared plus q plus 1 squared equals 18. But now the problem is we've got one equation and two unknowns. And that's a problem, because then you cannot solve the equation. You need the same number of equations as unknowns to be able to solve both of them, or all of the unknowns. But in the previous question we showed that q is equal to 2 minus p, and therefore we can replace the q with 2 minus p. So let's do that. So over here we've got p minus 3 squared plus, and now instead of q we'll have 2 minus p. So we'll have 2 minus p plus 1 squared equals 18. Okay, let's multiply out these brackets. Then we get p squared minus 6p plus 9 plus, and now this, 2 plus 1 is 3, so we just have negative p plus 3. Okay, so negative p squared is p squared, and we've got plus 3, so it's plus 6p, and 3 squared is 9, plus 9. Okay, equals 18. Apologies, let me just cancel out this line and start again. That'll be, multiply that out, we get p squared minus 6p plus 9 plus negative p plus 3 squared will give us p squared minus 6p plus 9 again, and that's still equal to 18. So now let's just collect our like terms. We've got p squared plus p squared will give us 2p squared, minus 6p will give us minus 12p, and 9 plus 9 will give us 18. That's plus 18 equals 18. Okay, now we can take the 18 across. That'll cancel out with that 18 then. So we'll have 2p squared minus p, 12p, equals 0. We can divide both sides by 2 and we'll get p squared minus 6p equals 0. And we can factorize out a common factor here. We'll have p minus 6 equals 0. And so either p will be equal to 0 or p will be equal to 6. But we can clearly see that p is not equal to 0 because it's positive. So p has to be 6. Now to find the q value, we can just substitute p back into the equation. And this equation would be the easiest because we know that q equals 2 minus p. Therefore, if we substitute p equals 6 in, we get q equals 2 minus 6. Therefore, q equals negative 4. And that looks like it could work. So p is 6, q is negative 4. Now let's write that in here. 6 and negative 4. Okay. Let's see what other questions they have for us. Number 6.5. Determine the equation of the circle having center the origin and passing through n. Okay, so we're going to move the center to here, but it will still pass through n, so it'll just be a bigger circle. So now, again, we know that the equation of a circle is x minus a squared plus y minus b squared equals r squared. Okay, and if the center is the origin, it means our a and our b values will be 0, because that's the center of our circle. So x minus 0 squared will just be x squared. X minus y minus 0 squared will just be y squared. And now we need to find what our radius is. The radius would be from the point n to the origin then. So we need to find the distance between O and n. And we've calculated p to be 6, negative 4. This is 6 and negative 4. So now we've got to use the distance between n and O. How do we calculate the distance? Well, that'll just be a Pythagorean calculation. So we need to find the distance between O and n. That is equal to our radius. And ON, in terms of real values, is equal to, well, ON squared is equal to, it'll be 6, or the values of p and q, so it'll be 6 squared plus negative 4 squared. And ON squared, therefore, is equal to 36 plus 16, and that is equal to 36 plus 16 is 52. So ON is equal to the square root of 52. Now we can simplify that as well. The square root of 52 should work. So we have as our equation x squared plus y squared equals square root of 52. And just to see how we would simplify it, let's have a look at how do we simplify a surd. We can do that by getting this number into its prime factor form. So let's say 52, and it can divide, first prime number it can divide into is 2. That leaves us with 26. We can divide that by 2 again to give us 13, and the only prime number, 13 is already prime, so it can only be divided by itself. But we can factor out 1, 2 because it's a square root sign, so that'll be equal to 2 square root of 13. So let's just rewrite this. X squared plus y squared equals 2 times square root 13. That's our equation. 6.6. Calculate the area of the circle centered at M. So that's the area of our original circle. How do we calculate the area of a circle? Well, that is just area of a circle is equal to pi times the radius squared. So this is equal to pi times, and the radius of our original circle, let's find where we calculated the original circle equation. That is our r squared. So our radius of the original circle is square root of 18. So pi times square root of 18 squared. So that's just 18 pi. And there's your equation. There's your value for the area of the circle. 6.7. Calculate the ratio in its simplest form, the ratio NP over MP. Okay, let's have a look at the picture again. So NP, this distance, divided by this distance. Okay, well, what we can do is we can use the properties that we know of so far. Let me just draw in this straight line here quickly. Okay, well, we know that this angle is 90 degrees. That's part of the properties of a tangent to a circle. This is also 90 degrees. And then we know a quadrilateral, the angles inside a quadrilateral must add up to 360. So we've got 390s, we need one more 90. And so that'll tell us that this is a square because these two adjacent sides are equal. They're both the radii of a circle. So that means these two are also equal. That gives us a square. Okay, so now what do we do with that? Well, mn over mp, what did I ask? np over mp. np over mp. So this side divided by that side in its simplest form. Well, we know that since these two sides are equal and this is 90 degrees, we've got a right angle triangle, and the ratios of the sides would be 1 to 1 to some hypotenuse value. Well, let's see what that would be. So in essence, what we have is a triangle of this form. Two sides are the same ratio, same length. So what would this side be? That would be the square root of 1 squared plus 1 squared, which is 2. So this would be the square root of 2. And now, in terms of this, mn, np, those would be the sides of ratio 1, and mp would be the long side. So this would be m, n, p. So now they ask us for the ratio of np over mp. So that'll just be 1 over square root 2. So np over mp is equal to 1 over square root 2. There you go. That is question 6, analytical geometry focusing on circles.